All right, this is the ingenuity graphing polynomial functions, the assignment part. All right, so first slide, we're going to be testing the end behaviors. So the end behavior, all you need to do is look at the leading term. Okay, so in this case, we're going to be testing out x to the fifth power. Okay, so here is what they're asking. If x is going towards the negative infinity, so this is basically saying that x equals to negative infinity, what does y equal to? Okay, so this is how we analyze it. Negative infinity to the fifth power. Okay, you have a negative infinity or any negative value by multiplied by itself 5 times, you're still going to get negative infinity. Okay, so you're going to say that y equals to negative infinity. So the first blank, you're going to put negative. Okay, all right, so the next thing you want to do is to analyze by what happened if x is going to be a positive infinity. Okay, so think about that positive infinity to the fifth power, multiply itself 5 times, you're still going to get positive infinity. Okay, so y is going to equal to positive infinity. So you're going to put positive in the second blank. All right, so this is how you're going to do it. You're going to factor the x to the fifth power minus 9 to the x cube. You want to factor this. Set it equal to 0 because we're actually looking for the x-intercept. So y must equal to 0. So you know that f of x is y. Okay, set y equals to 0. Okay, and then we're going to factor out the x cubed from both terms. So you're going to get x squared minus 9. And then the next thing you want to do is keep that x cubed. And you're going to factor more to x plus 3, x minus 3. Okay, understand that each term, I'll put a parentheses over here, each term inside the parentheses have set it equal to 0. We're going to go ahead and solve for the x. So we know that x cubed equals to 0 means that x equals to 0. Okay, and then x plus 3 equals to 0, so x equals to negative 3. And we got another one, x minus 3 equals to 0 means that x equals to 3. Now we're going to be talking about something called the multiplicity. So multiplicity, basically you just have to look at the exponent. So this is basically saying that not just one x equals to 0. If you further just analyze this, okay, I'm going to put this on the side. X cubed equals to 0. Basically you're having 3 x's equals to 0. Okay, that's why you have a multiplicity. This is what we call, because it happens more than once. It actually happened 3 times. So this is what's called the multiplicity. Okay, so here the ones you have to check are going to be, see, this one is for negative 3. It happened once. So you're going to put negative 3 with multiplicity of 1. And then this one is when x equals to 3 and it happens once, so the multiplicity is 1, and 0 with the multiplicity because it happened 3 times, so multiplicity 3. Okay, so what's next is that the graph of what's going to happen, because all of them, all the exponents are odd numbers, so I would say odd values of exponents. If it's odd value of exponents, you're gonna see the graph crosses the x-axis. Okay, so let's look at what are the ones that are true about this polynomial function. Okay, so first of all, you need to know that there is one turn, so I call it T1, and there is another turn, I call it T2. So the number of terms plus 1 is going to be, so the number of turns plus 1 is going to be your highest degree. Okay, this is the easiest way to analyze it. Usually it's going to be that way, okay, but sometimes it's gonna have some hidden roots that you can't find. So in here you can roughly just say that your highest degree could be x to the third power. You know what? In some cases, it could be x to the fifth power. Don't even worry about it. Just need to know one thing. Okay, it's going to be a odd number degree. Okay, so the next one you want to check is going to be look at how many zeros, so how many x-intercepts you have. So 1, 2, 3. Okay, so you're going to say that it has exactly 3 real zeros. These are all the all the zeros, real number zeros. Okay, and then two more things you have to check. So none of the zeros have even multiplicity, because you look at it, the function passes through across the x-axis. It crossed the x-axis. It crossed the x-axis. Means that these are all odd multiplicity. Okay, so you want to check the second to the last one. If you guys look at this, this graph kind of look like, if it's an odd multiplicity, kind of looks like this. Okay, this function is negative x to the third power. Okay, so which means that your leading coefficient is going to be negative in this case. So check all those four. All right, so what is the end behavior? Okay, so all you need to do when you're talking about end behavior is looking at the x to the fifth power. Okay, so what's going to happen here is that if you have x is approaching to negative infinity, think of it, that negative value to the fifth power is still going to be a negative. Okay, so which means that your y is going to approach negative infinity. All right, so let's use a different color. What happened if your x is approaching positive infinity? So I'm basically saying that positive to the fifth power is still going to be positive, so your y is going to approach positive infinity. Okay, so the one you want to check is going to be letter B, or the second one. Okay, so the graph touches but does not cross. This is basically saying that there's a bounce back of the graph when it hits the x-axis. This is because the multiplicity is even number. Okay, so how do I know that? So let me erase this part and then show you what happened here. Oops, I can't erase that. Okay, so let's just rewrite this function. So x to the fifth power minus 8x to the fourth power plus 16x to the third power. And then what I'm going to do here is that I'm going to factor it. Okay, this is my f of x. I'm going to factor it. So I'm going to factor out the common factor. It's going to be x to the third power. So that'll left me with x squared minus 8x plus 16. Okay, you further factor it to x cubed times x minus 4 times x minus 4 set equal to 0. You can write x minus 4, combine them, so that'll be x minus 4 squared. Okay, so let's just solve for the value of x. Put the parentheses here. All right, so we know that set it equal to 0, set it equal to 0. So x equals to 0, 0, and x equals to 4. And then let's check the multiplicity. Multiplicity is 3 for m equals to 0. Multiplicity is 2 when x equals to 4. Okay, so the first one right here, it says the graph does not cross. That's when x equals to 4, because that's an even number of the multiplicity. And if the graph is going to cross the x-axis because of odd multiplicity, that's because when x is equal to, that's when x is equal to 0. All right, so let's look at the next one. So this is actually a pretty easy one. All you need to do is set everything equal to 0. All the binomials equal to 0. You're going to find out that x equals to 3 x equals to negative 2, x equals to positive 1. Okay, now you can go ahead and determine the multiplicity by looking at the exponents. So multiplicity is 2, multiplicity is 2, multiplicity is 1. Okay, so which one has a multiplicity of 1? Look at it. Okay, so just 1, when x equals to 1. Okay, which one has the negative 2 has a multiplicity of what? It says right here, the one I circle, 2. Okay, so this is basically talking about the multiplicity and how the graph is going to look like on the xy axis. So the one that only touches and not crossing is going to be for the one with even number of exponents. Okay, what about the one with the crossing the x-axis? It's going to be odd. All right, so let's look at the next one. All right, so the 0 at the functions are, so let me put x's on them. These are all the x-intercepts basically. The 0 is basically saying x-intercept. Okay, so we got negative 2, we got 0, we got 4. Okay, which one has a multiplicity of 2? So if it has the multiplicity of 2, that means that your graph, when you hit the x-intercept, is going to bounce back. Another one bounce back. Look at this. Everything crosses. See, I'm coming from this way, and when I hit the x-intercept, I just went through it. Okay, and I went through it, and I went through these zeros. Okay, so you're going to say none right here. So none of the zeros have multiplicity of 2. Okay, so how do you determine the whether the function is positive and negative? Okay, so you're gonna have to break it by using the zeros. So these are all the barriers you have to start breaking the function apart. So we got the first part right here. So this part right here, okay, it's gonna messy. Negative 2, comma, and then negative infinity. Okay, and then for this part right here, it's going to be negative 2, comma, 0. Okay, let me use different color. For this part right here, it's going to be 0, comma, 4. Okay, the last part towards the positive infinity is going to be 4, comma, positive infinity. Okay, so check the second one. Okay, so what's going on